So I just want to do some notation first. So we have sequences. So if you have, say, 1, 2, 3, 4, 5, and so on, that's a sequence. And these are terms. So this would be the first term, T1, that would be T2, that would be T3, and so on. Might as well put in T4 and 5, since only 2 more. So that's what we mean by T1, T2, T3. And we refer to the general term as Tn. So in this case, Tn would equal n. Because if I want the first term, T1, then I just set n is equal to 1. So n equal to 1 is the first term, because that's T1. And when n is equal to 1, the right hand side is equal to 1. So we have that T1 is equal to 1. And if we want the 50th term, we just say T50, which is equal to 50. In our general arithmetic sequence, the formula is Tn is equal to a plus n minus 1d. So that's the initial term, and that's the common difference. So d is the difference between successive terms. So in this case, we're going 1, 2, 3, 4, 5. We're increasing in steps of 1. So d would equal to 1. So in this case, a is equal to 1, because that's our initial term, and d is equal to 1. And we're doing that because you can see from the sequence that the difference is 1. And you could also work it out, because if you take any two terms, we know that Tn minus 1 is equal to d. So the third term minus the second term is equal to 3 minus 2, and that's equal to 1. So that way we could just work out what d is. And if we know what a and d are, then we can plug them into, this is our general formula. If we know what a and d are, we know what the value is, what the numbers are, we can just plug them in to the formula. I'll call that star. So if a is equal to 1 and d is equal to 1, then star gives us Tn is a. We know a is equal to 1, plus n minus 1 times d, and we know that d is equal to 1. So we can expand that out. We can say that's 1 plus n minus 1. And then we can go, well, 1 minus 1 is 0. So that's equal to n. So if a is equal to 1 and d is equal to 1, then Tn is equal to n, which we knew at the start. You know, we could just see the sequence and write it like that. Now, in the question, I mentioned that a is equal to 3 and what t5 is equal to 18. So say you knew that. Running out a bit of space. So in the same way, you know, here I said if you knew that a was 1 and d was 1, we could work out what tn is. Here, if we know a is equal to 3 and t5 is equal to 18, well then we can use the general formula, like tn, for all arithmetic sequences. This is true. We have an initial term and each of the subsequent terms goes up by a factor of d. So if a is equal to 3, for our general arithmetic sequence, well, we know a is equal to 3, or we've been told that a is equal to 3, then t5 is equal to 3 plus n minus 1, well, in this case n is equal to 5, so 5 minus 1 d. And we know, like we've been told, that t5 is equal to 18. So 18 is equal to 3 plus 4d, using our general expression for arithmetic sequences, and using the fact that we know that t5 is equal to 18, and using the fact that a is equal to 3. So if we know we're talking about an arithmetic sequence and that a is equal to 3 as well as t5 is equal to 18, then we can actually work out what d is. So we take away 3 from both sides. So 18 minus 3 is equal to 4d, and that's 15. If 15 is equal to 4d, then we can divide both sides by 4 to get d is equal to 15 over 4. So then we know that a is equal to 3 and d is equal to 15 over 4. We can plug that into, you know, if we know what a and d are, then we know what the general expression is. So then we know that tn is a, which is equal to 3, plus n minus 1d, and we now know that d is 15 over 4. So that's our general expression for the terms in our arithmetic sequence. Finally, Sn is that's a sum. So 1, 2, 3, 4, 5, they're elements. That's a sequence. 1, 2, 3, 4, 5, 6. Or 106 there. And each of the members of this sequence, the terms, are like t1, t2, 3, t4, t4. Sn is the sum of t1 plus t2 plus ... So Sn is the sum of the first n terms in our sequence. And actually one more thing. So also you can't say that t5 minus 1 is equal to t4. That's not true. T5 is the fifth element of our sequence, and T4 is the fourth element. Now actually, in this case, the common difference is 1, so T5 minus 1 is equal to T4. but not in general. In the sequence we were talking about, the common difference, d, is 15 over 4. So in the sequence which had a is equal to 3, like the initial term is 3, and where t5 is equal to 18, in that sequence t5 minus 1 is not equal to t4, because that 5, it just says it's the fifth element of the sequence. t5 just means n is equal to 5. So yeah, if you have t5, you just plug in n is equal to 5. So where you see n in that formula, you just put in a 5. That's what t5 means. And t4 means you use n is equal to 4.